Hello everyone, welcome back to my tutorial. In this tutorial we are going to solve this I section beam with the static analysis. So this is a section I have taken. So it has a material of steel with an Young's modulus 210 gigapascal and Poisson ratio is 0.3. So here we just want to apply the force of 1000 Newton. So one side we are fixing completely, other side it is a roller support. Now we'll model this beam. So solve by using a salome meca. First we'll define the cube. So I'm keeping this beam in x-axis so that it is easy. So here I'm just giving 0.02. Y also x is just 1 meter, I'm just considering. So 1 meter length. Y is 0.02. 0.02. Let's see. 0.1. 0.1. So instead of using this, we'll model this by using a sketch. So 2D sketch. So we'll define into XY plane, we'll extrude into Z axis. 0, 0. This is I'm just keeping 0.1. 0.1. 0.1. 0.1. Fit screen. So instead of 0.3, 0.4 I'm giving. So this one is 0.1 and 0.4. Just apply and close. The same sketch. We just wanted in translation in y-axis of 0.5. 0.4 will keep. Just apply, and the same sketch will make it sketch 1 rectangle, 4 and 0.2. 0.1. 0.4, and this is I'm using 0.1. Yes, just apply and close. Now we'll translate this sketch to translation 0.25. Zero, 0.25, 0.2. Actually this total length is 0.4. Just apply and close. Now this is okay. Now we'll build the face to all the sketch. First one, just build the face. Just apply. This one also just apply it, and this, not this one, this one. Okay, then you just go to Boolean, just fuse it. Now we have created the I section. Now we'll extrude this face. Go to generation, extrusion, vector, This is in XY plane, OZ. Just 1 meter. Very small length. Just 3 meter. Yes. Just given 5 meter. Now I have created this eye section. Now we'll create a groups to apply the boundary condition. Before that, I'm just saving this file. Pictures, code aster. So eye section. Now we'll create a groups. Edge group. So this edge has to be fixed. Just apply. This edge has to be roller support. Roller. Just apply. Here we need to apply the pressure. So force of 1000 Newton. Create group. So force. Apply and close. Now I have saved it. Now we'll go for mesh module to create the mesh. Mesh, create mesh. Go for NetGen 1D 2D. So here simple parameter 0.05 source, 0.05 I'm giving. Just say OK, apply and close. Right click and compute it. Now we have created this state element. This mesh is enough. Now just go to aster study to create the setup. Just say OK. So we can use the assistant to generate the setup. Add a stage with assistant. Here use isotropic linear elasticity. Next. Here also just give next. This also just next. So here just dummy fixed, you just give it fix. So here there is one more support which is a roller. So roller support, that is in the XY plane. It has to move in the Z direction freely. Remaining 2 direction it has to be fixed. So here we have to apply the pressure of force 1000. Just finish it. Pictures, code aster, eye section. I'm just giving name of result.rmed. Just finish it. So all the setup I have created. Now we'll solve this case. Before that, we just go to post processing, call champ, constraint and criteria. This one is SIGM LNO and nodal value. Here we have to calculate the SIEQ LNO and nodal value. Use this previous name, just apply and OK. Just go to output, just edit it, call champ, tau champ, make it yes, just say OK, just apply and OK. So we have read the mesh. This is the 3D model. Material is a elastic material with a steel material property. We have assigned the material to the model. Here we are fixing. Here we are applying the pressure. Fixing and roller support and pressure here we are applying. So this one is the result data. It is a solver. It will static solver it to do. Then finally output. Now we'll solve this case. This is simple linear static analysis of eye section. Just wait for a while, it will solve and it will show the results. Now it is solved without an error. Now just go to the paraviews to do the post processing. This one is the displacement. This one is the displacement magnitude. If you want to see the displacement in y direction, so here you can see these two are minimum displacement of 0. Here it is going in the negative direction. So you want to see the wrapped by vector, just give some value, just apply it. So this way it will get deformed. To see the results in rainbow blue to red, just make it, this one you just make it 12. So this way result will show. This one is the displacement in y direction. Example, you want to see the stress, meca stress. Similarly, just change this color into blue to red. So this one is the meca stress. Here we are getting a less stress. That's why we don't need a material here. So here it is compression, here it is tension. So this value we can see it in the signed von Mises. Just go to von Mises signed. Here you can see the tension, it is a positive. Here it is a compression, it is in the negative. So like that we can see. Similarly, we can see the stress in the sigma x directional stress, sigma x, sigma y, sigma z. We can see the same stress of this one. So this way we can view the results. So thank you for watching my videos. Please subscribe my channel for more videos. Thank you.